Very good morning, and thank you very much for giving me an opportunity to share some of my thoughts to the young students. And also, I'm very happy to that the principals and also the management people are here. It's indeed a great pleasure, and uh, I rarely give it to school, but I don't know whether we are little faster and so on. But pedagogy, there may be some time we are different, but I hope that I will try to manage it. So my title of today's lecture is Biomimicry. It's learning from nature. So the idea of this particular lecture is how you can learn a lot of things from nature. It is not only your uh, if you want to cool your mind or other kind of a thing, but also all the technology and science and even economics comes from nature. So let us little more uh, concern about the nature and observe the nature, and so that we will be able to get some more ideas. In fact, what the ideas which already have been done, it's only around 5% of the nature's well-tested technology or ideas. So let me go take you through some of the examples of biomimicry. First, let me talk about what is biomimicry. Then we will go through some examples, and uh, towards the end, we will try to see some conclusions or what we wanted from you. That's a lecture of mine. So, if you look at the waves of innovation, so the first wave was mainly, in fact, the iron, which were the invention, then water power, mechanization, textiles, and commerce. The second wave, which is around 1845, it is more in the rail engine or steam power and steel, cotton. And third wave is the most electricity, chemical, internal combustion engine. You can imagine before 1900, there is not much of electricity application. Then fourth wave is more on petrochemical, electronics, aviation, and space. Fifth wave is digital networks, biotechnology, software, and information technology. And the sixth wave, what we are currently talking about in the 21st century, is sustainability, biomimicry, green chemistry, industrial ecology, renewable energy, green engineering, and nanotechnology. These are the areas that the sixth wave have brought down a lot of other things. Okay. Now let us just look at. I don't know. You might have seen this particular slide somewhere, but over the years, because almost if you look at it from the current position, almost around 4 billion years ago only, the life has started. That is what the historical or geological research says. So, and if you look at it, these are all many evolutions have come. So, evolution of cells with nucleus, and there are many things that it comes over here. And this is a Jurassic period. Then, and maybe animals, and elephant was around 5 years, and we are the human who was started is only around 3.8 billion years. Please remember, this is billion, that is billion. So in fact, the latest one is human. Okay, whereas there are other animals which have been working for a longer period, but unfortunately we took over all this nature and then tried to supersede all the people. That is a major point, that what it is being looked into it. But the idea is, over the 3.8 billion years, there are many tested concepts, ideas, and also some processes or forms which were sustainable. What you are seeing now, the many natural systems, these are all have been tested over 3.8 billion years. That means that is the concept which can be sustainable. Okay, so we are talking about sustainable for only one or two generation, but the concept which have been over the years that have been proved around 3.8 billion years ago. So whatever it is remaining now, they are all successful models. So that way, the biomimicry, the theory behind biomimicry is that natural processes and systems have evolved over several billion years uh, through the process of research and development on its own, commonly referred to as evolution. A reoccurring theme in natural system is a cylindrical flow of matter in such a way that there is no waste of matter and use very little of energy. In fact, the concept in nature is there is no waste. Unfortunately, this term has come to us, and we always say that it is waste, waste, waste. But there is nothing called waste in nature. So, whatever you are putting as a waste, that will be used by somebody else or some animals or some microbes. So let us look at little more carefully. Learn from the nature there is nothing called waste, and instead that's a resource. Okay, that's the first point which I would like to tell. And if you look at the type of economy in over the period in nature, so the first and foremost, the old economy is tiger economy. The tiger economy is, you might have studied about tiger. Whenever it becomes hungry, then it will try to kill something and then drink their uh, blood or take the thing. But on the other hand, if it is not hungry, it won't go. Even if there is a deer pass through that, it won't do anything. So that means it is whenever you need something, you go and attack other countries and take away all the material. Okay, that was a tiger economy. The second economy which was evolved is monkey economy. So monkey economy is, it's not only on the food, but also for anything you always try to take it away from other people without any contribution. So monkey never contribute anything, but it takes away all the things. So that's second economy which were there prevalent in the world. The third one, which has come, made a lot of changes, what is called economy of honeybee. So, economy of honeybee is everyone has to work. You might have heard about China or Russia. This is basically the communist principle where everyone has to work and everyone has to earn their bread and butter rather than some people earn and some people suffer. So, contribute their share and effort in obtaining the products. So, this is what the Russian model or Chinese model, but that also now it is not working very well. Then it came to what is called mother economy or economy of services, because there was thinking, especially in 1972 Rio de Janeiro conference, it was decided that those countries which are rich or affluent, they should take care of the other countries. So even we have received a lot of fund from USA during the famine, during 60s, 70s, and so on. So they are all what is called mother economy. You try to give something services and also ask them to come up in line with that. And now the last economy, which is now prevalent, what is called green economy. So this is what's called economy of environment. So it's nothing but you do anything but improved human well-being and social equity with less environmental and ecological risk or damages. So this is what is called economy of sustainable development. So now we are going through this particular one. So mostly anything that you are looking at it, look at on the environmental angle. So today there are challenges. The world is changing because of economic recession, loss of stability, rapid market changes and quick cycle, environmental and social instability, open source, new media, networks, corporations. So what we have to look at is we should be more adaptive, agility, resilience, and networking. These are all needed for sustainable development. And these characteristics, if you look at it, adaptive, agility, resilience, networking, the nature is the best example that you can look at it. So if we want to solve all these problems, then we have to look for the nature. Then only we can go for what is called sustainable development. In fact, nature is much more economical about all processes than what we are doing. So in fact, we are more the sixth sense, having the sixth sense, which would be much more economical. But unfortunately, it is not happening. But you are the people have to start looking at it little more in a different angle. So let me just take you to what is biomimicry. Okay, all of you know mimicry. Mimicry is your imitating somebody. Okay, so we always look at somebody talks like other person, but biomimicry is you try to imitate the nature or imitate the life. So the to imitate the life or nature, that is what is called biomimicry. So viewing nature as a role model or a teacher or something that you can take. Nature has already solved many of the technological sustainability problems that we face today. Learning from nature is not about nature, but you try to learn how to live with that or how to utilize it for the human well-being. Okay, so taking the design process or principle ideas from nature, biomimicry refers to human-made processes, materials, devices, or systems that imitate nature. So you are here copying is allowed. There is no copyright. So nature is not going to put a case on you if you are taking an idea. So that's a way that you can imitate nature process, nature forms, or the shape, or ecosystem, and possibly not the products. Don't try to cut the trees, but try to learn something from trees. Learn something what's the form that they are adapting, and also the ecosystem. So my lecture is more concerned about on this how we can take different forms or ecosystem or processes, but definitely not the products. Okay, so whatever it is naturally available, if you are gone destroying, that's not a good thing. Biomimicry is you try to take the idea or imitate it and use it for your human beneficial purpose. So, the I would say the mother of biomimicry is Venus. Okay, she was very fascinated about nature, and she is a technical engineer, but she wanted to do lot of work on this relating to technology, how it would have come from the nature. So, if you look at it, many times any ideas there will be some connection to the nature. That is what her viewpoint. So she is, and she wrote a good book, Biomimicry: Innovation Inspired by Nature. So this is available in the net. If you want to read it, it's not a very long book. It's a very small, but lot of information that it has there. So in fact, this book has galvanized scientists, architects, designers, and engineers in the exploring new ways in which nature successes that can inspire humanity. It is not changing nature, but rather incorporating its natural ideas and design to improve efficiency, conservation, and sustainability effort. So I think when you have time, please read this book. It will be wonderful book. Okay. So why pay attention to nature? What is that new thing about this nature side? Let us just see some characteristics, which how it will be helpful for your uh, this not only for technology, even for your own life. You have to learn from this thing. The first one is the nature runs on sunlight. Okay, it never produces energy, so it always runs on sunlight. The nature uses only the energy it needs. It never uses excess energy. Whereas, unfortunately, we use lot of energy, air condition, maybe 5 air condition in a room. These are all that not required, but unnecessarily we are utilizing it, and it is very difficult now to change the character. Nature fits form to function. So any place that it will automatically, any natural system, trees or anything, it will automatically fits form to the function. Nature recycles everything. Please understand that. Unfortunately, we don't recycle. Even when earlier we were very good in recycling, but that now the society has changed quite a lot. And nature rewards cooperation. So this is, that means within a small area there will be a good thing, and each one will give the energy or whatever it is to the other one. And also nature banks on diversity. Suppose you have a small area, you may not be able to have only one tree, one type of tree in all the area. But on the other hand, if you have more diversity, now you can come with a very good forest. That is what is called Miyawaki scheme, Tamil Adarvanam, that's what they call it. So nature demands local expertise. So it never demands somebody has to come from USA or UK. Nature curbs excess from within. In case the water is not available, it drops off the leaves, and then there is no problem as such. It adjusts with what it is available. But unfortunately, nowadays we don't have this kind of a habit. We always say that I need that particular one on any count. We are not able to adjust with, suppose 1 hour power is not there, we are not able to, we try to get tensed and so on. And nature taps the power of limit. Especially the meaning is it always optimize. It never use anything excess what it is needed. So this is that book, what it is, the 9 basic laws worth of mimicking. So you can, if I want to see the wastewater or solid waste, look at this. Okay. If you want to come out with a function or design a new system, look at this. And for forestry, you look at this, or diversity, you look at it, and always look at on the local expertise. Don't always have a fancy towards foreign products. And this is very important. And also the, and all of you know Steve Jobs. He has told that I think the biggest innovation of the 21st century will be the intersection of biology and technology. So biomimicry is that intersection. Okay. So I think we should look at that. Just switch up. Right. Now, the history of biomimicry is goes back to, all of you might have heard about Leonardo da Vinci. Okay, so fascinated by the phenomena of flight by the birds, Leonardo da Vinci, father of biomimicry, produced detailed studies on the flight of bird. So he made all the measurements and of birds, arrangement and everything. And he has designed several flying machines, including a helicopter powered by 4 person, which was finally he could not work out. But later on, the Wright brothers have been very successful. But the idea was from Leonardo da Vinci asset. That was a first biomimicry attempt. Okay, try to take from the nature, and then this we also have a good song in Tamil. Paravaiye Kandan Vimanam Padaitan. The same thing, Leonardo da Vinci, and you can just see this is his own drawings. If you go to internet, you can just see how he has worked on the flight details, measuring all those minute details. Okay. Then now let us look at on the 4 point that please look at nature as a teacher. That means whenever you face with a problem, you go to your teacher and then try to get understand. The same way, when faced with a problem, try to go to nature. What organism need to solve the same problem to survive? What would nature do in this particular question? So if you ask this question and then try to look around on the nature, it you will be able to get some good idea. Then inspiration. So Look to nature for transform society, water, energy, materials, food, how they are doing. Okay. And invention, some processing what it is there, try to solve the same similar problem. Information, life adds to the form of shape and structure. So you can take it as a teacher or inspiration, invention, or information. So that way, nature has everything. We will see one by one why we are saying these things. And if you look at it, just a comparison between uh, human or we and nature them. We always go in a linear fashion. We never have a, uh, we take the material and waste it and it will be linear. There is nothing called uh, uh, non-linear or something. It is more centralized. It is individualistic. We all work on individualistic, independent, inflexible, and singular. Whereas if you look at it, them, they always have a circular economy. That is what I was telling. There is nothing called waste. Everything will be reutilized and decentralized, cooperative, interdependent. So each one is dependent. You might have studied about carnivores, all those things in your biology. All of them are interdependent, even if it is something is going adaptive and redundant. So you yourself can think over if you can change your own style of working or style of living to this particular one, you can think of. So really, it will be very good. So our results, because of these particular characteristics, we deplete lot of natural resources, habitat loss, climate change, endangered and extinct species, persistent bioaccumulative toxin, dependence on petroleum too much, and lot of problems. Whereas for them, if you look at it, life creates conditions conducive to life, energy only from sunlight, material synthesized at ambient temperature using local materials, no toxic pollution, no waste, and no problem. So, can we not change our thinking or to this particular one? That is what it is needed. So, let us look at the three aspects. Let us look at the form, that means the shape or the what way that it is there, and process, what is a natural process that it is there, and ecosystem. Okay, so we will just see some examples of mimicking the form or the what is a design, and we will just give some examples like kingfisher, car design, and velcro. Okay, whereas mimicking the process, how is it made? Paint from lotus leaf, building inspired by termite, and also maybe low cost materials. And mimicking ecosystem, in fact, the wastewater treatment system is inspired by phytoremediation, which is a natural wetland treatment as such. So there are many processes which are natural process. People are looking at it. So let us go one by one. This is the first example which are being talked about it. So biomimicry looks to nature and natural system for inspiration. So after million years of or billion years of tinkering, Mother Nature has worked out some effective process. In nature, there is nothing called waste. Anything left over from one animal or plant is food for another species. Inefficiency doesn't last long in nature, and human engineers and designers often look there for solutions for modern problems. Let us just look at something like this. So let me take you to the same thing I am reproducing here. One of the problem is many times Japan is known for a lot of speed trains, but it goes underground and then like our metros and then come out. When it comes out of the tunnel, when the train moves, it pushes all the air, and on the outside suddenly the air comes out. So when there is one media to other media, lot of thing comes out, then there are two things that it will be happening. One is there will be a lot of noise, another thing, lot of vibrations. So the train had lot of vibrations when it comes out of a tunnel, okay, or an underground side. So then people made a lot of complaints and so on, and because they asked for compensation, because of this sound I lost my uh, hearing capability and so on. So then it becomes a big problem for the people, especially those who are operating the railways. Then the chief engineer was from the government. He was given a big banking. So what he did it, he just went to a river nearby. He just wanted to relax because he was so much upset that the government is not happy with his thing. Then he was just looking at different birds and he was seeing a simple kingfisher. The kingfisher, where when it goes inside and take a fish out of it, that it does not make any noise or any disturbance. Normally, even if you put a small stone on that, there is ring of waves will come. But here he found that there is no disturbance when the uh, beak went inside the water and it takes without any disturbance. So immediately he got an idea. Then he asked one of his junior engineer to get a kingfisher, okay, and he made all the measurements of this particular one, and that he designed the front portion of the speed, because you remember this is around 1000 kilometer per hour or 700 kilometer per hour. So after he made exactly the same design, he found that, or it was found that there is no noise and also the vibration has reduced 90%. So that means he was so much happy that Kingfisher has helped him, the nature has helped him to solve the problem. Now, every the, the train or the bullet train, this is called a bullet train. So, these bullet trains have been designed based on the Kingfisher beak. Okay. So, the second one which you might not have any time that you might not have noticed. You might have seen lot of termite mound on your whenever you go anywhere, any village or anywhere it is available. But you may be always seeing that in a movie that there will be snake inside. Okay, but the snake is not going inside to eat the termite. Please understand that. So the termite is, it has a very good engineer. Okay, why I am saying is depends upon the outside, whatever be the temperature, inside it will always be very between 25 to 30 degrees C. Even if it is desert where the outside degree is around 50, 55, inside it will maintain that it will be. So this is one of the deserts. That's why the height is so high. Okay, so and it will make a ventilation such a way that it will be the air what it is. This is a mechanism. The air what comes and then goes out. So this area will be very cool. Okay. So on the other hand, if you want more heat, what it will do is it will add some more thing to get more air inside. Okay. So it is a best engineer or original natural engineer. So this idea, whatever be the outside temperature, suppose you wanted to have an AC in your school, you just borrow this particular idea and then try to create a building, and this building was created the same way as a termite hill. Okay, so they it is in, we'll see that building. So this is how it is uses a free energy and ventilate as such it is possible. Nobody teaches engineering to termite, but it does very good work. So depends upon the outside climate, it will make either on the, so the same way that it is there, it has been created. Okay, so and this is how that it is. You can just see this is what it is inside, how the air comes and then goes out. Okay, and this is a termite. So very good without any, and inside always it will be 24 to 25 degrees C. You can design that. So that is what it has been taken and then put down into. It's in Zimbabwe, this particular complex, and they have built based on that particular concept. So, and the termite dens look otherworldly, but they are surprising comfortable places to live. The temperature inside the termite den holds a steady at a comfortable 26 to 30 degrees, depends upon. And Mick Pierce, an architect of Eastgate Center, Zimbabwe, studied the cooling chimneys and tunnels of termite dens, and he applied those lessons to Eastgate Center, which uses 90% less energy to heat and cool than traditional buildings. The building has large chimneys and that naturally draw the cool air at night to lower the temperature, and of the but during the daytime these slabs retain coolness, greatly reducing the need for supplemental air conditioning. So this innovative building is considering only less than 10% of the energy used in similar size conventional building. So automatically you get, without any air conditioning, you will be able to get the same temperature. So the lesson is learned from termite. Now you can tell me why snake is going into the termite hill. It only because it cannot tolerate the temperature. So it knows that inside the termite hill the temperature will be cool enough. That is why the most of the snakes are getting into the thing and then live there. Okay, so of course it lives along with them. Okay, right. So the second example, the form, what we are seeing is this is what is called kaku. Kaku is nothing but Tamil palli. Okay, so this feet has a peculiar kind of arrangement. You can just see these are all some of the photographs of the foot of the kaku, or so this Keku, if you look at it, so if you take a microscopic view, this one and that, if you go for further thing, you can just see even under a small keku, you can get all these so many what is called setae. Okay, the Kaku toe pad is climbed to vertical surface. Even on glass, it will go away. There is no problem because what it does it with this thing, it applies a pressure. So automatically the compression holds that particular thing very well. Okay. So mainly a good adhesive surfaces and so on. And now using this, we are now using what is called our post-it, or even the your uh, Spider-Man, or anything, that these are all based on the same principle that they have. Toes and spider filament might inspire innovation in glue adhesive. We have also a small post-it. So all of them have the same principle as this particular one. And also nowadays on textile industries, it is very much useful as such. Okay. Then another example is the Velcro, okay, or Tamil சொன்னா நாயுருவின்னு சொல்லுவாங்க. So whenever you go somewhere, it will immediately catch up. If you take a microscope look on that particular one, there is lot of the small thorns which are coming on that. Wherever it was, it's a process of pollination or dissemination kind of a thing. But this will quickly hold the thing, anything that it is there. So now based on this, we have this velcro in all zoos or anything that we are coming across this particular one. So that's the inspiration by a scientist. Okay, so this is Velcro is a widely known example of biomimicry. So this was invented by a Swiss engineer, George de Mestral, after he removed birds from his dog and decided to take a closer look at how it is worked. Under the microscope, he noted tiny hooks at the end of the bird's spine that caught anything with a loop, such as clothing, hair, or animal fur. These small hooks found at the end of the bird needles inspired him to create now what is called velcro. So okay, so this you have two part of the system. So one is on the hooked material and the hook. So without this material we may not be having this lot of places. And also in other countries there is called velcro jumping, a sport what it is there. This this is velcro jumping. So you can just put your child on the thing. He will be uh, hanging on that without any problem. So people, especially the kids, enjoys like anything. This is a vertical one. Okay. Another one which is a very natural inspiring. Okay. So this is a box fish. This is called a box fish because it looks like a box, but it has a history. The history is from Daimler. Daimler is an automobile company. So they found that their car had lot of accident, especially when it is getting turned from one street to other street. If there is a turning, then always this particular thing get into problem, and people were little hesitant to take this particular car because many of the cars which had things. Then he, the same way as the engineers were struggling hard, and one has seen this box face, that it goes straight, and then also on the right side 90-degree it will make a turn without any disturbance or meeting the other thing. So then he thought that this shape is going to be the major problem, major good thing. So they have done the car exactly the same way as that of the box fish. That is what the Dieter Kuttler, a top engineer, Daimler, so was asked to design a new aerodynamic car. For inspiration, he turned to nature and looked at the fish. He discovered the box fish was the one nature's most efficient mover with excellent aerodynamics. When swimming around its home on coral reefs, the box fish stops and starts and zigzags with ease. It even has a reverse gear to go back into the small holes. So its shape was imitated, and this car was the engineer's design outcome with 20% less gas consumption. So or petrol consumption. So when they have done an analysis on aerodynamics, this becomes the best aerodynamic car. So they made it the backside little up and so on. So this will be a without any disturbance. So even if you are going under a stormy wind, there won't be any problem as such for this. So that he got inspired from box fish. So then people have put on from the shark, which is the fastest moving. So there is a lot of swimsuit nowadays, which has been prepared exactly the same arrangement as that of the skin of the shark. But in fact, the actually, the Olympics, the Michael Phelps got 8 gold medals, but later on, people have made a case that he has used this particular shark thing, and because of that only he win. And it is the award should be, or gold medal should be given to the shark rather than to Michael Phelps. Okay, but you can just imagine that this the same shape as that of the shark skin, if they have done it. So in fact, under the electron microscope, the shark skin is made of a countless overlapping scale called dermal tentacles. Okay, so you can just see that it will be. I think that. Okay, so there is. So that the it is a good formation. The same formation, if you do it, you don't have much resistance, so the swimmer can go very fast. So that was the main thing. And there are 43 new suits which are people are now utilizing it, and 9 world championship, have been only by using this particular one. Okay, and also please remember this also scientists have developed surface in hospital that resist bacterial growth. The bacteria can't catch hold on the rough surface. Okay, so this is again dolphin, whale, and whales on a long time. And what the main idea is, so this also the whale fin increases the efficiency. So now lot of turbines have been developed based on this whale fin. Okay, so and people have come out with a lot of designs, homes based on exactly what it is there in the nature. And you can just see this is inspiration based on which they have come out with this particular one, exactly the same dimension as that of it. So inside it is very good. Okay, so in fact it has a good purpose of collecting rainwater, collecting sun and shade and breeze, and also the every side that you can see the views also. Okay, so the now uh, many of the sports car you might have seen that. Uh, can you just tell me, uh, any one of you, which one would have inspired for a car, design of a car? Any answer? I'm giving three choices. Please.
ஒருத்தர் வந்து சொல்லு மகா
Eh, it, okay. It is tiger. Okay.
Cheat, cheat, cheetah,
Cheetah.
sir.
Okay. Okay. So cheetah, because if you can just see that the curve when it goes very fast. Okay, so you can just take that particular exactly the same dimension, and he has taken photograph. He can't go and measure it, but he has taken photographs and then made a good measurement and designed it, and that made the good sports car. Okay, so you can always imagine that why the sports car is like this is mainly on this. And this is, I am just drawing one line which is inspired by this tiger. There are other two lines also which have been drawn or designed based on the same tiger. Okay, so try to find out. Okay, this is totally three. In automotive design, there is a maximum that all the great cars are defined by these three great lines. Okay, so one line I have drawn. Please try to draw. Make imagination. Find out which are the things that it is uh, reflecting the same thing. Okay, so you can easily see that, but I am just giving you. So the other two lines. So another one which we are also maybe you should understand, many times that we think the straight line is the most efficient way of travel. Okay, we always wanted to be travel, but actually the nature always travel in curved lines. Even if you take a river or anything, the traveling, if you look at it, mostly it is curved line, and the most efficient way of curve is Fibonacci series. You might have seen in the mathematics, people or the teacher will be teaching the Fibonacci series. That's one of the, in fact, if you fit this snail, it exactly the Fibonacci series. And based on this, we have now designed a good turbine where the water movement, the resistance is very, very less. Okay, water flows. That is the main, and also the second one, the best, never on straight line. It will be better to be curved or on circle. So why we are saying circle during the tsunami of 2014, most of the structures which are circle in shape did not get affected, even it is especially the uh, uh, mainly the Kalangarai Vilakam, all those things have not affected because it is in circular shape. Whereas a straight building or a rectangular or square building got immediately damaged. So that is what we may have to learn from nature. So, and even our bones grow in spiral, hair on our gut and our cells are all arranged in spirals. Water mixer for the thing nowadays we are using this kind of mixing so that the chlorine use is less than uh, and you can just see this is a good animal. If you see the arrangement inside the cell, it will be like a turbine blade. So now people have come out with a good turbine blade. The water will come and then the energy will be generated if I use the same thing as that of this. So a company has taken up and used this impeller and aerator based on this particular shape and which are very efficient, reduce the resistance and reduce the friction loss and automatically more efficient. And other forms, so there are, you can have many forms which are being utilized. So people have used, especially on coastal structure, the same way, and also the and let us just look at on the uh, mimicking the form. So this is a dolphin on the back side. So now that means it is very strong. It like a cantilever. So you can smoothen the point, and now people are applying, especially on coastal area. The bus shed will always be like this. If you go to Texas and other places, so the idea is that if you are sitting below that, there won't be any problem that it will fall down. Okay, so if you similarly, this is a natural form of this particular thing. So you can people now go for many. You can make a chair like this. You can make another bowl like this, or anything that you want different shape as it is there. This is a table, dining table. People have done it. So any form that if you take from nature and then create a system, it won't fail. That is a lesson from the form as such. So now let us look at quickly the process. So the process is something all of you mainly might have seen the lotus flower or lotus leaves. We know lotus flower, but mostly lotus leaves, if you look at it, uh, there won't be any water that it will be staying there. That's why we call that tamarai, like tanir bola. So, but if you look at it, take some time, take a leaf and then look at under the microscope. So you will see a big kind of this will be the microscopic view of the lotus leaf. So whenever there is some, even if a dust is there, and if there is a rain, so all these things will be going as a, what's called a snowball effect, that it will go down very quickly. That means no dust will be sticking to the surface as such. The surface of, even though it looks like very nice, but it is more bumpy and this causes water to surface contamination, anything that it is there. But now people have come out with the paint which is exactly the same properties as this. So the German company ISPO spent 4 years researching this phenomena and developed a paint with almost with similar properties. That means if I paint it and if there is a rain come, so the house is completely cleaned. You need not every 4 years or 5 years that you have to paint it as such. So that is the main advantage of this particular one. So and we have even the windshield wipers or car wax, and even if you have seen on the road, people put a small light. So this was also mainly invented based on looking at nature. One person, when he was driving, he saw a cat eye. So he thought that that is a very good indicator. So he has created the light as an indicator light on the road or uh, thing based on the cat eyes concept as such. So this is the lotus effect, and you can just see 1 micrometer and 10 micrometers. So any dust which is forming will get washed off quickly. So the when the paint dries, so another thing is you can just you have to learn from bugs also. It is this called a Stenkara beetle. Is a master of water collector. Okay, so from morning frog, from ocean, especially from ocean, what it does it is, if the fog is formed, it opens. You can just see on the top there are a lot of holes. So each one is a container. So during the fog time, it will just store it, and whenever it becomes thirsty, it opens that inside and then take it. And similarly, uh, you might have seen the camel. Okay, hope all of you have seen the camel. Camel has a pump, especially at the center. You might have worried why or wondered why it is having a pump as such. Actually, that is a storage place for water. So if it is water is now it feels bad, then it takes the water from that particular area as such. So each one has something that it is. So now researchers have been able to build a concept inspired by this for rainwater harvesting. Okay, and even from air, how you can collect water, that the impact is from this thing. You can just see here how the drops are getting inside. And there are whatever your computer, everything is based on our peacock and also butterflies, the different color. Okay, so you need not paint for a color, you can just create the same thing as in butterfly, you can create it. Okay, so and the spider web is the most strengthened one what it is there, and now people are making the especially on self defense coat. Okay, or bulletproof coat. These are all made from the same phenomena as in the spider. So they have used the same process to get the, and nowadays we are going for what is called nano textile. So this nano textile is same as the paint. In the textile, you create that kind of a structure so that whenever you, if you are going into the rain, your shirt will be washed out. There is no problem that every time that you need not put a soap and all those things. So it just you have to put it inside water and take it out. Your shirt is very much clean. So that is what, and this is much more thing. There is a self-healing plastic people have found based on how, suppose somebody get a small injury, how it is getting cured. Okay, it may take around 7 days or 8 days to cure, but the same thing is accelerated. The main problem is the flight. Many times that some birds or something is hitting, if there is a small hole or something puncture has come, in fact the flight will fall down. So to avoid that, what they have it, all those places there are some plastics. So whenever there is a small thing, so it automatically moves into that particular place and close it very quickly. That is what is called self-healing plastics. So people have found out mainly based on the natural materials. Okay, so and what unfortunately the nature has used, if you look at the chemistry, has used only 5 polymers, which are harmless polymers. But unfortunately, we use almost around 300 polymers, which are not, thanks to the chemistry people, but people have used these for a wrong kind of a concept. So we are getting a lot of plastic waste in that. So we may have to look at on how the green chemistry can work on it. So this is also one of the polymer. Okay, so nature works with carbon, hydrogen, nitrogen, and oxygen, partly with CaCl, MgP, MgPK, and but the we have only even metals which are available in our bodies are also very trace metal, but uh, and these metals are very low in animals or other living species. But what happens to our thing that we are utilizing a lot of these heavy metals and other things in the industries which are going into the thing, automatically that will spoil the environment. So let us just look at this car. So many times that you might have seen, the car get accident, the bonnet will have a problem. It will be completely damaged. So engine also is there. It will be. So somebody has looked in it how to do that. in that. So the toughest thing will be the horn of the rhinoceros. So they have used that kind of a material, and now even if it is hitting another big wall or a steel, it won't get damaged. So people have developed strategies based on the nature. So artificial photosynthesis that you can create based on the same photosynthesis what it is in the nature. People have used hydrogen fuel cells and so on. So based on, and this is again a glowfish. So in the dark aquarium, so but developing how it is getting a glowing even underwater. So that they have developed, the people have used this logic, how the same process now all the glows have been developed based on the glowfish, and even our own temperature side, how it is. That is what we are giving it. In case you want to find some problem in your body, you send a barium or something. Mainly it is for the glowing. The glowfish only the same concept that what we are using. In fact, now the robot has come from just a cockroach. Okay, so the same way that the first robot was built based on somebody has made all these analysis and develop equation and then develop the thing. Okay, so that's what inspired autonomous robots. And on the process side, we have as I have said, in fact Japan, they have developed a city exactly as a forest. Okay, so uh, the same as a soil food web, and also the industry also should be of what is called the symbiosis industries, where all of them are the finally there is no waste. That means symbiosis in the sense one industry's waste will be a raw material for the other one. That is what is called. Then in Singapore, Denmark, they use this particular one, so that overall from the industry there is nothing called waste or zero liquid discharge and so on. So this is the food and water today. We are still following the uh, linear one. So fertile, from you create food and use that and become a wastewater, and then it goes into the river. We build up phosphorus, nitrogen, and so on. But actually, it should be supposed to be a circular loop or close to circular economy. So from the soil, you get food and then utilize it, biogas plant, and then again try to put it in the soil. So then the river also is protected, and you are also utilizing that. So we have to move from the linear and mixed kind of a thing to a closed loop and separate system assets. So that is what the linear economy. There's a lot of waste. Okay. So the raw material, you apply energy, water, and then produce waste, as well as after consumption also waste will come. Whereas in circular economy, there is nothing called waste. Everything is coming back to. So we also take the natural treatment by wetland is equivalent to the wastewater treatment. The same process have been studied and then we have used. And I would like to give you a small problem. So if you might have gone to Ooty or Kodaikanal and so on, this is a red sandwood. Okay, so this redwood grow for more than 200-meter height, but this will take the water from the bottom all the way it goes up, and try to pump it throughout 24 hours, 365 days, and also for so many years without any problem. But we are not able to pump out water for only for 2 floor or 3 floor itself. So what shall we do? Can we not learn something from this redwood thing, how it is being pumped? Emulate it for the pumps design. That is what they are, Cornell University is doing, and also Utah University, they are working on how this tree capability can be used for taking the water to bring up into the buildings. So I'm trying to complete my lecture. So people have used now classical example for transport design. So even uh, for the Japan underground thing, they wanted to find out what is the nature I have to put it. So they went and find out again. They have taken the termite as an example. So the termite route they have taken as a transport route exactly the same way, and thermoregulation design, what we have seen as a termite, built environmental designs, material science design, agroforestry, and defense. And in fact, there are many applications of biomimicry in defense. You may not be knowing, but we can, and cleaning and health, all of them are you can learn from nature. So let us go for life principles circled rather than a linear. Life creates condition conducive to life, and optimize rather than maximize, leverage interdependence, benign manufacturing, life adapts, life means nature, adapts and evolves, locally attuned and responsive, integrates a cyclic process, and also it is resilient. Resilient means any problem that it comes like a flood or drought or tsunami or anything, it will come back to the original position very easily. So to conclude, nature has been showing us for centuries how well it works. We have only just to begin to pay attention on that. Nature has already figured out how to avoid this problem or solve a problem. Look to nature as a teacher or role model. Use nature's ecological design principles or process or the form to inspire engineering projects. Switch over to linear economy, from linear economy to circular economy. So even nowadays people are talking about low temperature physics or the lightweight material. Lightweight material was invented by one of the scientists when he was walking on the beach. He just took the shell, which is commonly available, and tried to break it. It was not breaking, but it was very, very less weight. So he went inside how the shell is formed, and based on that is what is called low temperature physics. So you can create the um, uh, low weight or uh, mainly weightless material by in the normal temperature. So you have to go for a low temperature physics, and he has created a thing. Mainly the calcium has to be put down into the low temperature to get. So the lightweight material he has evolved based on natural process. So every inventory nowadays we talk about nanomaterial. Nanomaterials are already there in butterfly. Okay, we are only get the color from the nanomaterial. So everything that only thing is you have to bring it. That's why it's called research. So you try to again research from nature. You need not go for any big guide, but nature is a guide. Okay, so I think with that I'll stop here. So even this is a very nice arrangement. So you can't create that. Let us salute the nature and also value the nature, and you can be a very good scientist or engineer or a good politician also can be there. Thank you for your attention.